In today's video, let us look into some of the examples of sp3 hybridization. So one of them is methane Ch4. So I have written down the structure of methane here. It has a bond angle of 109 degrees 28 minutes. This gives rise to a tetrahedral structure. Hybridization is sp3 hybridization. Shape or geometry of the molecule is tetrahedral and bond angle is 109 degrees 28 minutes. Number of bond pairs is equal to 4 and number of lone pairs is equal to 0. Now how do we arrive at the structure of methane? Atomic number of carbon is 6. So 1s2, 2s2, 2p, 2. So I can put them in the boxes. So this is your first 1s orbital, this is your 2s orbital and this is your 2p orbital. 2p orbital has subshells X, Y and Z. So we are going to fill these electrons into these boxes. These are nothing but, the square box is nothing but your s orbital. Okay, how many electrons are here? 2. So I have written 2 electrons. How many are here? 2. And then how many are in p orbital? 2 electrons. So before they get paired, they have to sit alone in the orbital like this. Right? So this is the arrangement of electrons. Now in excited state, one of the electrons of 2s orbital jumps to, this electron of 2s orbital jumps to 2pz orbital. So this is our 2p orbital, this is X, Y and Z. So one of this electron jumps to 2pz orbital and I have this particular arrangement of electrons. Once this is done, in excited state, this 2s orbital and 2p orbital, they mixed together to give you, how many orbitals have mixed? 4 orbitals. So they mix together to give you 4 new orbitals having same kind of energy. Yesterday I had told you what they should be called as. They have characters of both S as well as P. Therefore each of these orbital has to be called as sp3 hybrid orbital. So I am writing sp3 hybrid or giving names to each of these as sp3 hybrid orbital 1, 2, 3 and 4. And how many electrons are there in all these 4? 4 electrons. So arrange them in these hybrid orbitals. Yes. So this I can show it in the form of orbital structure. This is for what? For which atom I have written? Carbon. How many sp3 hybrid orbitals are there? 4. So 1, 2, 3, 4. What is the name of these orbitals? sp3 hybrid orbitals. Right. I am going to show them. Now how many electrons do they have? 1 each. So I have written 1 electron each. Right. What is the structure of methane? Ch4. So what is the configuration of hydrogen? Hydrogen is 1s1. Which orbital? S. S is spherical in shape. So one hydrogen atom comes here and it shares its electron with a carbon atom, which I am showing it with pink pen here. So how many more I need? 3 more. So second hydrogen atom with its electron, third hydrogen atom with its electron and fourth hydrogen atom with its electron. So these orbitals are suspended at an angle of 109 degrees 28 minutes. Why? Because when they are suspended at this angle, they will have minimum repulsion and maximum stability. Understood? When you are studying hybridization, we will start with why the structure of methane is like this. The structure of methane is like this because the carbon atom in methane undergoes sp3 hybridization and it goes on as I have shown. Since all these orbitals have single electron, they are said to be involved in bonding and they form pairs with other atom. Hence they are called as bond pairs. Are there any lone pair of electrons here? No. So number of bond pairs is equal to 4 and lone pair is equal to 0. Okay. Now what kind of hybridization is seen in ethane? Ethane, ANE, So it should obey the general formula of alkane CN H2N plus 2. So its formula is N is equal to 2. Eth means 2 carbon atoms. So C2H 2 to the 4 plus 2 6. So this is the structure of ethane. 1 yes, and one more hydrogen atom here. Right, this is the structure of ethane. And how many sigma bonds you have? 1, 2, 3, 4, 5, 6, 7. There are 7 sigma bonds. 1 sigma bond is between carbon and carbon, and 6 more are between carbon and hydrogen. Now coming to the hybridization, in organic chemistry you had seen if there is single bond, it should show sp3 hybridization. If it is sp3, then with no lone pairs, it should have tetrahedral geometry. Okay, and bond angle should be 109 degrees 28 minutes. So we will look into how we arrive at this structure. Now what is the hybridization of carbon atom here? sp3. So there should be 3 sp3 hybrid orbitals. 4 sp3 hybrid orbitals I have shown here. sp3 1, 2, 3 and 4 with how many electrons? With 1 electron each. But how many carbon atoms are there in ethane? There are 2 carbon atoms. Very good. So sp3 hybrid orbital 1, sp3 hybrid orbital 2, 3 with 1 electron each, and the 4th orbital, I am going to show it here, it overlaps with sp3 hybrid orbital of the neighboring carbon atom, giving you a sigma bond. Done. So it is the sigma bond between carbon and carbon. Now what is the number of electrons in hydrogen? 1. So what is, where it is sitting? In s orbital. So one hydrogen atom will come with its 1 electron and forms a bond pair here. Similarly another hydrogen atom, first, second, then I have third here, 4th hydrogen atom, 5th hydrogen atom and 6th hydrogen atom. So this is regarding the structure of ethane. Ethane is a saturated hydrocarbon, carbon-carbon single bond. If it is carbon-carbon single bond, sp3 hybridization. If it is sp3, it is tetrahedral. If it is tetrahedral, bond angle will be 109 degrees 28 minutes. How you can explain? Carbon is sp3 hybridized. Therefore, it should have 4 sp3 hybrid orbitals. So I am writing the names of these hybrid orbitals here. So 4 sp3 hybrid orbitals. Same is true for the other carbon atom. Why I have taken 2 carbon atoms? Because there are 2 carbon atoms in ethane. So sp3 hybrid orbital of one carbon atom overlaps with sp3 hybrid of another carbon atom to form a sigma bond. Which sigma bond? Formed between carbon and carbon. And on the same lines, a bond is formed between carbon and hydrogen atom. sp3 hybrid orbital of carbon atom overlaps with s orbital of hydrogen atom to form carbon-hydrogen sigma bonds. Hope you have understood the structure of ethane. Now we shall look into the structures of ammonia and water. Ammonia. Atomic number of nitrogen in ammonia is 7. So its electronic configuration will be 1s2, 2s2, 2p3. We shall try to put it in the boxes here. So this is 1s orbital, then this is 2s orbital, right? And then you have 2p orbital. So 1s has 2 electrons, 2s has 2 electrons, and you have 2p orbital here with 1 electron each. Now here what happens is there is no jumping of electrons from 2s orbital to 2p orbital, because half filled and completely filled orbitals are more stable. They just undergo hybridization. So in excited state, what happens? 2s orbital and 3p orbitals mix together to form 4 hybrid orbitals. How many s orbitals have mixed? 1 s orbital. And how many 3p orbitals? How many p orbitals? 3 p orbitals have mixed together to form 4 new orbitals having same kind of energy. So 1s and 3p. So together 1 plus 3 is equal to 4. So sp3 1, 2, 3 and 4 orbitals are formed. How many electrons are present here altogether? 2, 3, 4 and 5. So you need to arrange them in these 4 orbitals. So initially they will sit singly and then pairing takes place. So pairing I have done here. So how many lone pair of electrons you have here? 1 lone pair and 3 bond pairs. So what are these boxes? They are nothing but orbitals. Now I am going to give them the shape of the orbital. So I have nitrogen here, nitrogen, right? And sp3 hybrid orbital 1, 2 and 3 and the fourth one. So fourth one is slightly placed away from the all other 3. So you have this pair of electrons I have shown here, lone pair, and how these are bond pairs with single electron here. Understood? Now according to VSEPR theory, there is maximum repulsion between lone pair, and next is lone pair repulsion is maximum compared to lone pair, bond pair, right? So here then we have bond pair. So maximum repulsion is seen between lone pair, then lone pair, then bond pair. So here you have a lone pair and you have a bond pair. Therefore there will be repulsion. Because of this lone pair, bond pair repulsion, this bond pair is pushed downwards and hence the bond angle, which should have been 109 degrees 28 minutes as seen in sp3 hybridization, is not 109 degrees 28 minutes. It is less than that. Understood? Yes. So this bond angle decreases from 109 degrees 28 minutes to less than that. And here I have only one single electron. So another electron from hydrogen comes and overlaps here, giving you NH3 molecule. Hope you have understood. Once again I will explain. The outer electronic configuration of nitrogen is 2s2 2p3. So these orbitals, s orbital and p orbital, they mix together to form 4 sp3 hybrid orbitals. And how many electrons they are having? They are having 5 electrons. So one is lone pair, the others are bond pairs. Okay. So bond pairs, they overlap with hydrogen atom to form, nitrogen, hydrogen sigma bond, and lone pair is left alone as it is. Because of lone pair, bond pair repulsion, the bond angle decreases from 109 degrees 28 minutes to less than that. So what is the bond angle in case of ammonia? It is 107 degrees. And because of that, what happens to the shape? It will not get tetrahedral shape, but it will have a pyramidal shape. So it will have a pyramidal shape. So in sp3 hybridization, with one lone pair, then you will have pyramidal shape. Okay, so we'll move on and look into another molecule of sp3 hybridization. We shall look into another example for sp3 hybridization with 2 lone pair of electrons. So water is an example. So atomic number of oxygen is equal to 8. Its configuration is 1s2, 2s2, 2p4. I have written the boxes, in which I am going to fit the electrons now. So 1s2, 2s is having 2 electrons and p is having 4 electrons. So singly they occupy like this. And this is the fourth one. Okay. So these are present in the oxygen atom. So I am going to write oxygen in the center. Right. How many is now before that what will happen? 2s orbital and 2p orbital, they undergo hybridization to give you sp3 hybridization. Why sp3? 1s and 3 p orbitals have mixed together to give you orbitals having same kind of energy. So you get 4 sp3 hybrid orbitals. And how many electrons altogether they are having? 4, 5 and 6. So I am going to fit them into the boxes like this. 4, this is the 5th and this is the 6th electron. So coming to the structure of water, I have central oxygen atom. How many sp3 hybrid orbitals? 4, 1 and 2. This is third and the fourth sp3 hybrid orbital. How many lone pairs are there? So there are 2 lone pair of electrons and 2 bond pairs, right? So these 2 bond pairs are overlapped with hydrogen atom with its 1 electron. So this is s orbital, 1s orbital of hydrogen. This is another hydrogen atom with its electron, and you have here 2 lone pairs which are not involved in bonding. So because of lone pair repulsion, they are placed far away from each other, these 2 orbitals. And here, due to repulsion between lone pair and bond pair, the bond angle drastically reduces from 109 degrees to 104 degrees and 8 minutes. It is no more 109 degrees. Why? Because according to VSEPR, there is repulsion between lone pair and also lone pair and bond pair. As a result, the bond angle decreases from 109 degrees 28 minutes to 104 degrees. As a result, the structure of water no more remains tetrahedral, though it is sp3 hybridized. So it will have a bent shape. And what is the hybridization? sp3. Bent shape. Bond angle is 104 degrees 8 minutes. So in sp3 you have come across 3 examples, yes, wherein there is no lone pair, there is 1 lone pair, athwa you can say 0 lone pair, 1 lone pair and 2 lone pairs of electrons. So which is the example for 0 lone pair? You have example of methane and ethane, C2H6. For 1 lone pair you have studied ammonia, and for 2 lone pairs it is water. What is the shape if you have 0 lone pairs? It is tetrahedral. If you have 0 lone pairs, it is tetrahedral. If it is 1 lone pair, it is pyramidal. If it is 2 lone pairs, it is bent shape. In the next video, I shall be talking about sp and sp2 hybridization. Thank you.